Hi, I'm Rich with insideHPC. We're here at ISC'14 in Leipzig, Germany, and we're at the CoolIT Systems booth. And I'm here with Geoff Lyon. How are you doing today?
Doing great, Rich. Thanks.
Good, good. Well, thanks for hosting us. You know, I wanted to get the latest on what you guys were showing. So why don't we start the tour with kind of an intro? Who is CoolIT Systems?
CoolIT Systems is a specialist in delivering liquid cooling solutions for desktop computers, servers, and now specializing in larger data center implementations.
Okay. And what are you showing off here in the booth today?
We've got a variety of solutions depending on the applications that the customers are interested in. Probably one of the new things we'll get to in a minute was kind of a larger scale, but to start with what we had, it was quite similar to what we had last year. We have a AHx 35, so what we've done is adopted a naming convention which utilizes a number, which is the number of kilowatts that it can typically have as a capacity.
Okay, so 35 kilowatts for this.
Yeah, and this is a self-contained solution, so the nice thing about it is that you don't need to have liquid plumbed into the data center from the facility side. So it's nice to be able to have that high capacity performance, high density capability, but in terms of efficiency, it's not going to add a tremendous amount of efficiency because it's still actually taking all of the heat from the rack through a liquid-to-air heat exchanger, basically a giant radiator in there, and it has a fan construct which pulls the cool air in from the cold side and deposits all of the heat into the hot side. But then it's still up to the air conditioning of the data center to dissipate that heat. Now, the nice thing inside there is we've got dual redundant pumps so that if it's got failover capabilities, of course, and gives people comfort that there's low risk involved. But our modular structure allows us to have that hook up to our standard manifolds and our standard server modules, which we'll talk about in a little bit.
So what would the advantage of this be versus just, blowing air through a rack, right? Is it getting to that number?
Well, it's the ability to actually utilize liquid cooling's advantage inside the server.
Okay.
So most often if you had a very high-powered server, say it was 1.2 kilowatts or even higher with today's accelerator cards being 300 watts plus, and you've got 150 watt CPUs, people have created very dense form factors in to the point of, I think now we've got 1.5 to 2 kilowatts even in a 1U server. So the ability to dissipate that much heat with air is extremely difficult. But if you liquid cool it, then you've got the ability to have an extremely dense form factor for the entire rack, and having that go into the manifolded system, this is one of the options for dissipating the heat. Another one, which is what we have sitting right in front of us here, is a liquid-to-liquid heat dissipation module. This is what we call our CHx'14. The 40 would indicate that we've got an ability to easily dissipate 40 kilowatts, actually potentially even more if you have cooler liquid. We can accommodate facility liquid temperatures that would be, in the W2 to W5 class. Now what that means is right from chilled water, cold chilled water supply, right up to quite warm or even hot water cooling. So if you had liquid coming in at even 40 or 45 degrees Celsius, we've got an ability to dissipate a very dense heat load for the rack. Similar to the AHx, we've got dual redundant pumps that are built in. We have a proportional valve here which will govern the amount of water that goes through the heat exchanger from the facility, so that if it's really cold water coming in, then we're not going to develop condensation going with the coolant into the various different servers. We don't want to have any drips, obviously. In the control system here, it's actually nice to see. We've got different zones for leak detection. This is actually a sealed box so that if there is any drips or lack of liquid integrity, it'll actually be caught and then reported through the control system here. Level sensing, all the various different temperature and pressure data is kept and monitored online as well. So the big news for us this year is a much larger scale capability. So previously we were developing, rack solutions. Now what we've done is actually scale that up to what we have here. So this is our Rack DCLC CHx 650. So this has the capability of dissipating 650 kilowatts.
Okay, that is a lot of electricity. Okay, a lot of heat.
The heat is it's the same sort of equation of what we had before.
Uh-huh.
You know, we saw the pumps that were in the top over there.
Yeah.
If we have a look in here, they're significantly larger.
Yes.
Obviously, you see there we've got dual redundant pumping capabilities. Each pump does between 360 to 380 liters per minute, and there's a fairly sophisticated control system built in, such that every week you use one pump. It'll then switch over to the other, so that their service life is the same, and then you're guaranteed that you're not going to have the backup pump be dried out or potentially not working, and that be a surprise when you need it the most.
Okay, so a centralized cooling system for what, like a dozen racks, or how many?
Well, it just depends on the load, actually.
Yeah,
but
okay.
with 650 kilowatts, even if it was a very dense rack, you've got that could be 10 60 kilowatt racks. It
Sure.
could be 20 30 kilowatt racks.
Okay.
It really just comes down to managing the flow, and what our engineers do is we scope each project individually and make sure that we've got appropriate capacity for the implementation. And as you can tell, when we're going to much larger scale installations, this is an ability for us to actually put one module in for many racks, and then if we're doing larger scale, like say it's not just 10 racks or 20 racks, but 200, 400, 1,000 racks, then we've got an ability to scale to that without a lot of difficulty.
Yeah.
Now the nice thing about this solution, it's tried and true, right? It's the same sort of implementation that's been done by IBM since actually in the 60s they
Sure.
started doing it.
Yep.
Now the philosophy here is what's actually inside is a liquid-to-liquid heat exchanger, just like we had in the rack version, but there's some reluctance in these larger installations to having that high-pressure facility water going right to the rack, right? So what we've got is an ability to abstract the heat exchanging. This can actually be even in a separate room from the rest of the racks and the equipment. And then the lower pressure coolant we actually can see on the tubing that we have up here. We've got our coolant supply coming down towards the racks. This is a much lower pressure, typically at about a 1 bar level, and those are actually then feeding all of the manifolds at the back of the
Right,
racks.
so you don't have that fire hose kind of pressure levels coming through that portion.
That's exactly right.
Yeah.
I mean, now it sounds like an awful lot of flow still
Yeah.
with 350 liters a minute,
Yeah.
but it is governed by pressure.
Yes.
So that as you look at these types of systems, it's highly parallel. So each of these main feeds is supplying 42 here, 42 here, 42 here.
Right.
It starts to end up being a very highly parallelized system, and we end up with very low pressure drop.
Got it.
So it's a very comfortable and we believe very reliable system.
Yeah. Jeff, your guys were telling me about this thermal piping you use. It's kind of tried and true, especially here in Europe. They use it actually for the drinking water there.
Well, that for just about everything. In
Yeah,
fact, actually,
yeah.
they've been using it here for decades, and it's actually quite unique and something that we discovered is now being promoted in various different applications, whether it be hotels, commercial, or industrial applications.
Mm-hmm.
It's a polypropylene piping developed by a company called Aquatherm.
Okay.
And we love it because it's flexible, it's fast to integrate, it's easy to create manifolding with it, and it has a unique joining system. They don't use glue. It actually is a plastic weld where the things are melted with an iron and then joined together. It's actually really cool.
Oh, okay, so they're thermally coupling, so no chance for leaks, or you can pressure test very quickly, not wait around.
That's right.
Okay.
It's fast. Now, it's not something that we insist on. It's an option that we
Sure.
provide to our customers. Now, there are some that are more comfortable with traditional copper brazed assemblies, and that's fine too.
Okay.
So one thing that you'll find with CoolIT Systems is that we're actually about delivering what the customer wants, bringing the right technology for their application, and doing our best to be flexible and partner together with companies that potentially have other complementary technology. So it's I believe, a best of breed philosophy here, and we use partners for our couplings. We've worked together with a company called Eaton Williams. It's a CES group company.
Okay.
To bring some of our other technology applications in place. They have everything from adiabatic cooling, air handlers. So we feel like we're now becoming a solutions-based provider. We can actually come into the customer site, evaluate all of their requirements and needs, and then bring in the appropriate people and experts to deliver the entire solution.
Sure. And you're ready for scale with this kind of setup.
Yeah, we're pretty excited about this, and something that is pretty meaningful. And there's a lot of these companies around the floor that are. I mean, liquid cooling is here, and it's here to stay, and we're excited about being a part of that movement. There's a lot of really good technology that we see being implemented here on the floor.
Okay.
Guys like Acertech, there's Eurotech right beside us here. HP did their announcement here at the show. Bull. So it's clear that liquid cooling is definitely the way forward. So we feel well positioned in that regard.
Great. Well, it's great to see this from the outside. Can we see inside the server and what's going on there down at the micro
we'll have a look
level?
over here.
Okay.
So this is a super micro platform here that is one of Boston's product offerings. They have the liquid modules already integrated. So, to kind of back it up a level, what we look at is we've got the server module, which is the cold plates mounted to the heat sources, whether they be CPUs or accelerator cards, GPUs. Even in some custom stuff, we've done memory, VRs, you name it. So it really just comes down to the value proposition to the customer. Okay. And then you see the tubes exit out the back of the server, and then plug into the manifold. So you have your supply of cold coolant and then your return of the hot. And the nice thing that we've done in terms of integrating these solutions is we've developed a very low profile cold plate module. So it's only 15 millimeters tall. Okay. It gives us an ability to integrate liquid cooling into even the most dense form factors, whether it be blades or some of the more innovative stuff that we're seeing in terms of horizontal or open compute. We haven't yet found something that we can't fit our liquid cooling modules into with relative ease.
Okay, so how'd you do that? Did you take the pump out of this device and then squeeze it down to a passive kind of system?
Well, in actual fact, what we initially did with these is we removed the pump. So it's the same form factor, looks the same on the outside, but now we actually don't have the pump on the inside on those that are installed.
Okay.
But now this is actually removing it completely and utilizing the patented split flow technology that we've developed to have a very low pressure drop, a very high performance cold plate capability, and then various different retention options, which gives us the ability to go on to Intel sockets, AMD, PHY, NVIDIA, you name it.
Right. Well, Geoff, this is all fine and everything if somebody's building a new data center, but what about retrofitting? I mean, there are a lot of servers out there that are experiencing trouble with, heat and power and cooling.
Well, we found it's actually quite a unique and common scenario where people have a dedicated data center or cluster that they've got put in place. Relatively small room, maybe they're limited in air conditioning. We've got installations now taking place in several universities, Leeds, Binghamton, UNLV, where they were limited in terms of the air conditioning that they could bring in, but they wanted to increase their compute. So we've retrofitted things like Dell servers, HP servers, super micro platforms. It's all relatively easy for us at that stage. We just take off the stock heat sinks, replace them with our modules, and then have, as long as we've got an ability to get the tubes in and out, then we can liquid cool just about anything.
Well, that's very exciting. So it sounds like the future is very bright for liquid cooling, and you guys seem to be at kind of the apex of what's new and exciting. So congratulations.
Thanks a lot. I mean, we're on a bit of a tear. We feel really good about it. We are on our third consecutive quarter of record revenue. People are excited about our technology, and we're happy to work with them.